Hi guys. We're continuing today with more solving systems by graphing. Remember, a system is a single problem that has two equations in it. When solving by graphing, our goal is to see where the two lines cross or intersect, and our final answer is usually an ordered pair. Today, we'll be focusing on our special cases where the final answer is not an ordered pair. Here's our first example. Don't forget for this section that graph paper is mandatory. So if you need to pause and go get a piece of graph paper to take notes on, do that now. In this example, I've already put both of the equations into slope-intercept form so we can get straight to graphing. Remember that on these problems, you need to graph two lines on your coordinate plane so that I can very clearly see how you found your solution. Let's go ahead and graph the first equation. For the first equation, I will be starting at the positive 1 on the y-axis, so I'm going to go up 1. And then for my slope is the number in front of the x. Now, right now, there's just a negative sign in front of the x, so my slope is negative 1 over positive 1. Don't forget, when your slope is negative, that means that you're going to go down, but you're still going to go to the right. So positive and negative slopes always go to the right. It's just a matter of going up or going down first. So I'll be going down and right, down and right. I can also go in the opposite direction, which would be a positive 1 over a negative 1. So up and left, up and left. And remember, we're not sure where these lines are going to cross. So we want to make as many slopes as possible so that we have a completely accurate line. For my second equation, I will be starting at the positive 5 on the y-axis. I'm going to go up 5. And the second equation has the same slope as the first equation. If you look in front of the x's, they both have a negative 1. And so I'll be doing the same slope that I did for the first equation, which is down and right or up and left. Now, if you remember from our previous chapter, when two lines have the same slope, they are parallel. And the definition of parallel lines are two lines that never intersect. Since our goal this chapter is to figure out where the lines intersect, if we have parallel lines, they will not intersect. And so we write that the answer is that there is no solution. Now, don't tell me that these are parallel lines. That was not the question. The question is, what is the solution to the system? Since they don't intersect, this has no solutions. There is no point where the lines will cross. Now, the only time you can write no solution is if you are 100% positive that the lines are definitely parallel because you saw that they have the same slope. If the lines do not have the same slope, then they have to intersect somewhere. And if they are not intersecting on your graph, that just means you didn't draw the lines far enough and you need to make them longer. This was our first special case for today. There is one more special case, so let's go ahead and try that one. Now, maybe you can already tell what this special case is going to be. We do have to graph, so I am going to go ahead and graph right now. So for this problem, I'm going to start at the positive 1 on the y-axis. And my slope for this problem is positive 2 over positive 3. So that's up 2 and right 3. Or I can do the complete opposite of that, which is down 2 and left 3. Notice that my line is sloping upwards because it has a positive slope. Now, when I go to graph my second line, I'm going to put a dot on the positive 1 on the y-axis. And I'm going to do a slope of 2 over 3. And I'm going to connect those dots. Now, the question today is, where do these two lines intersect? Where do they cross? Where do they touch? Since these are the same line, when I went to draw my second line, I drew it on top of my first line. And they touch everywhere on the line. Not everywhere on the graph, but everywhere on the line, these lines are touching. And so the answer for this problem, where we are drawing the same line twice, is infinitely many. Now, this is the only answer you can write for this problem, infinitely many. It is infinitely many because when we draw a line, we are drawing an infinite amount of dots, right? It's not just the dots that we did for slope, it's all the dots in between, everything on that line, all the decimals, all the fractions, and the line extends forever. That's what the arrows at the end mean. So infinitely many means all of the dots on the line. Just to clarify, you cannot say all real numbers for this problem. All real numbers implies that every single point on the graph is an answer. That would mean all of these points in the white space are a solution, and that's just not true. The only points that are solutions are the dots on the line. So make sure that you're using the correct phrase, infinitely many. This concludes our special cases for today.